Happy Friday, everyone. Today is September 29th, and this is episode 31 of Get Your Tech On, our shows on all things DOCSIS. I'm Brady Volpe, founder of the Volpe firm and Nimble This. With us is John Downey, the flavor of cable. John is also the CMTS technical leader at Cisco Systems. Welcome, John.
Thanks, Brady. Great to be back as usual. I'm surprised. What'd you say, 31 or 32?
We're on episode 31.
Wow.
Also with us is Asaf Matatyaou, Vice President Solutions and Product Management, Cable Edge Business at Harmonic. Asaf, welcome. Thanks for joining us.
Hello. Thanks for having me. Happy to have 31 as my first.
Asaf, you're also an extreme runner, and it's been rumored that you personally hand deliver some of your equipment to your customers through that. So that's one of your talents, we understand.
Yeah, you hear right. I just ran an ultra in West Virginia on the Appalachian Trails. Fantastic area to be in.
So, Asaf, where are you broadcasting out of today?
From San Carlos, California, just near our home offices in San Jose.
Okay. And John, you are not broadcasting from your normal location. We don't see any trophies or equipment behind you. So what's the change?
So I recently did a bodybuilding show at Penn State last Saturday. And so I'm up at Penn State, my old stomping grounds, visiting some family. And we were doing some staging for Expo out in Boxborough, Massachusetts this week. And I flew back into State College last night. So I'm actually doing this from my in-laws' house.
Yeah, looks like nice and comfort of a lazy boy, it looks like.
I'll try not to rock back and forth too much.
All right. Well, guys, thanks for joining us today. Today's episode will cover the topic of virtual CCAP. We know that both of your companies are, and I think a lot of other folks are working on this topic. We do want to cover the topic of virtual CCAP from how it benefits cable operators. And so that's kind of the gist of it. But before we get into that, I want to cover some topics in the news. Cable Labs has released an interesting video recently. They put out, it's called The Near Future. And I was looking through this video. I liked it because it focuses on technology that touches all of our lives. And this is, I think, important because it really focuses on everything that we do from a technology standpoint. And we're in tech. We deliver this technology to our subscribers, and they benefit from it. So I put out a bit.ly link that will allow everyone to take a look at this video. It's kind of interesting. The bit.ly link is bit.ly/the near future, all one word, all lowercase. So recommend everyone take a look at that, or go to the Cable Labs website, and you'll find that on there, also called The Near Future on the website. It's a short little video worth taking a look at. The FCC has made some updates on September 25th, just a couple of days ago. They released a report and order updating signal quality, aka proof of performance, on signal leakage for digital cable systems. So this is impacting QAM versus analog cable. In the order, the FCC modernizes their signal quality rules, and they're really focusing on a standard from the SCTE that we're all familiar with, the SCTE 40 2006. So SCTE 40 is the signal quality benchmarks for digital quality standards. So this is an update, and it is going to impact cable operators from transmitting QAM signals over their plant, from the standpoint of, yes, we are now going to start to have to worry about those and measure those. So that is an update, and so I'm kind of recommending that everyone go take a look at that, especially if you're an operator, as this will start to impact people moving forward.
Don't you think, I have to interject, don't you think the open market kind of dictates the quality anyway? I mean, it's not like we're a monopoly anymore. There's enough competition to say if your quality sucks, to put it bluntly, that they'll go somewhere else. And then on social media, people start blasting the crap out of, bad quality. So, I mean, do we really have to be, I know we have to have standards and all that, and we will, but for the longest time now, there was no real proof of performance for digital, right? It was all for analog. But the real proof of performance is proof is in the pudding. Meaning, if it's bad quality, your customers are going to go somewhere else.
Yeah, I think to your point, if you have if there's a lot of leaks in a plant, there's a lot of impairments in the plant, and those are ultimately going to show up in poor performance and qualm signals.
But that is different. To me, that leakage has nothing to do with our end customers' quality, because they see what they see. Now, leakage has always been proof of performance spec. It's RF, right? It doesn't matter if it's analog or digital. So CLI and that testing has always been there, so we don't interfere with FAA, with airplanes and stuff like that. But now you're talking about end-of-line performance, I believe, of a digital signal.
That's absolutely correct.
Yeah, and that's different. Ron Radek's been very involved in that. Ron is always involved in RF and ham radio and leakage and FCC proof. So he's been a very key, influential guy in that aspect. But I still think it's ironic, I guess, that I think the market kind of dictates a lot of this anyway.
Yeah, I do too, and I agree with you. However, I think either way, the FCC is still getting involved. So, we'll see. I do agree. And John, you did mention Cable Tech Expo. You're staging for that. That is coming upon us. That will be in Denver, Colorado. So if anyone's not aware, that's coming up. That'll be the week of from October 17th through October 20th. So I think all three of us will be at that show. I am not presenting. John, I think you are presenting. Is that yes, no?
I am, because you were supposed to be my co-presenter. Don't let Brady fool everybody now. He and I talked about co-presenting on DOCSIS 3.1 Lessons Learned, because he's got a lot of information, and so do we. But then just things come up, and we got a lot of stuff on our plate. And even when my first goal was to do 3.1 totally downstream and upstream, and once I started writing the paper, it became a lot longer than I thought. And usually when you do a presentation, you're doing it with another presenter from a different company or MSO, and they only give you 20 minutes or so, which, me, I'd go on a Segway. And
your opening agenda slide is normally 20 minutes, John.
This one presentation I did said I have one slide, but it's 3,300 builds in size 4 font.
Yeah.
So I'm doing it on DOCSIS 3.1 downstream lessons learned, Tuesday at 3:15. So the actual show floor doesn't open until Wednesday, Thursday, Friday. So there are workshops starting Tuesday. So I will be there Tuesday. Hopefully, you'll be around as well. I wanted to use you as a plant in the audience. But the other co-speaker in my workshop is Doug Jones from Cable Labs. So he's going to talk about, and I'm sure you're familiar with this too, is in an RFOG network, which you don't see a lot of RFOG networks. If you do DOCSIS 3.1 upstream, OFDMA, all those little subcarriers, looking at the spec, it's almost like saying taking multiple upstream channels from 2.0, 3.0, and if you have your neighbor transmitting the same time as you on a different upstream, a different scheduler, your two lasers come on at the same time, and that causes OBI, optical beat interference. So with DOCSIS 3.1, that's really going to be a problem unless you can figure out how to make sure any laser only comes on at one time, or some type of OBI mitigation techniques. It could be like the wavelengths on the upstream are slightly dithered, or figuring out which wavelengths are coming together at the same time. I mean, most of the RFOG stuff, the wavelengths are right around 1610 nanometer on the upstream, 1550 nanometer on downstream. But that 1610 upstream could be 1613, 1609, so a slightly difference in upstream wavelength. And that's assuming it's an amplitude modulated upstream laser. So, so Doug's going to talk about that, the fact that DOCSIS 3.1 upstream is going to be a hit on RFOG networks, unless just so you're aware of it. So he'll talk about that, and I'll talk about 3.1 downstream lessons learned, and the fact that it's a lot more robust than we originally thought, and we could run probably, in some cases, 4K QAM. In other cases, 1K QAM is going to be a no-brainer, but we could do 4K QAM and then rely on resiliency to check the modems, see how they're operating, and dynamically move them to different modulation if they need to.
All right, sounds interesting. So, folks, check out John's presentation on Tuesday. Asaf, you're going to be at the show? Yes?
Absolutely, yeah. Going to be there Monday through Friday, and I got a couple of speaking engagements. There's a session on Thursday for real-world deployment of a virtual cable hub, and on Tuesday I'm part of a panel of folks doing a remote PHY session on, I believe, Tuesday morning. Yeah.
Excellent, excellent. So, are those sessions that are advertised on? At
There's the remote PHY session that is advertised on the SCTE website, and the speaking engagement is the one on Thursday, which is there's a moderator and two other presenters as well, and I think there'll be each one of us will present, and we'll get a Q&A session, have some moderated questions. Looking forward to it.
But is the Tuesday session part of SCTE's extra charge, or is it a workshop?
I think so. It's called a session right now. It's I think it's a sponsored session. I think I saw the names. I think John Chapman's going to be there in the session. Tom Clunen's going to be there. Folks from other companies who are part of the event will be there as well. I think there's 6 or 8 different companies, including operators in there, and I think we'll have a good session talking about remote PHY and what it means to the industry.
Excellent. We will definitely look forward to it. So, hey guys, let's get into our topic today, which is virtual CCAP. As a shameless plug, I did an article. I was kind of inspired, Asaf, by when we talked at the ANGACOM show, but I did an article in Broadband Library magazine for this the one that just came out for the fall issue. So you can see that article on virtual CCAP either in the printed version, or you can see it online at broadbandlibrary.com. It's also on volpefirm.com on the blog there. And the article that I did is a very high level, kind of an introduction to what the concept of virtual CCAP is. And what I want to do here is, kind of socialize more of virtual CCAP, what it is, and how it benefits cable operators. So, my intro to virtual CCAP was kind of more like, what is virtualization and stuff like that. And I think we can kind of just start out here as well. What is virtualization? Why would we even consider doing it? We've had hardware-based CMTSs for years, and they've been working fine for cable operators. So, why are we doing virtual CCAP? And what is virtual CCAP? Either you want to start off with that concept?
Sure, I could start. First of all, virtual CCAP, I think, can be defined, has been defined by different people. Virtualization is such a broad topic and has been around for quite a while, actually. In your article, you mentioned virtual machines and how Wikipedia defines virtualization. And it's been around since the 60s, the concept of virtualization, obviously not for CCAP or for CMTSs. But the idea, of course, being that you're taking something that was once done in hardware or custom design and putting that on more general purpose or off the shelf type of hardware. It's not custom made. I think having things that are running in software is another premise of virtualization. So there's a lot of things about virtualization, like virtual machines, containerization, bare metal versus VMs. Those are all kind of different opinions and different points of that provide different value to the end user. And I think the bottom line, no matter what you do with virtualization, to start the topic, is there's a great benefit to the customer because it gives flexibility, agility for having software-based implementations, better feature capabilities, faster. Also, it gives you a sustainable growth approach. I mean, even with the hardware-based chassis, as great as we've done in the last 20 years in DOCSIS, after all, it's the 20th anniversary, right, of DOCSIS since 1997. We made dramatic improvements, but I think this is kind of where we want to have a sustainable approach to the growth that's happening in broadband. And I think virtualization is the way to get there. And we could go into each one of those things in more detail, but maybe I heard you guys talking about it a little bit at the Post Anga show session, and I heard John was very well. I'll let John speak for himself, but you guys had a great discussion about that as well. So maybe I'll let him talk about it.
Yeah. I mean, I would say it was a good segue from what the speech you're going to give on Tuesday at Expo, and this kind of ties into that, is what is really needed. It's kind of like, let's address the elephant in the room. What is really needed to even start talking about going virtual on the CMTS, getting rid of that hardware? Well, the physical layer still has to be there.
Yeah.
Well, where's this physical layer going to be located? Well, this means that Remote PHY is an adjunct or a precursor to even thinking about going virtual. So we got to get to Remote PHY first. Whether that's Remote Mac PHY or Remote PHY, that physical stuff still has to be out there. So where does virtual come into play? Greenfield, obviously, but brownfield, where you already have nodes, fiber optic nodes, amplifiers, stuff like that. Can I upgrade the node to an RPD, a Remote PHY device? Maybe. Is the play here and demographic maybe hospitality? I always said hospitality would not be a bad idea. If I was an integrator, maybe I could have a server farm running, if you want, quote unquote, CMTS code, running digital links out to all these hotels, and I just give them a Remote PHY node. Now I can offer them high-speed access, all the speed they need. I can take care of everything, the back office myself. I could be like, I'm even thinking about back in the days video with LodgeNet, like an integrator could go in and provide that service. Maybe like the old days where high-speed access used to offer internet access before the MSOs understood what internet really meant. Roadrunner was the sister company of Time Warner before Time Warner really knew how to do DHCP and everything else with IP. And maybe that's what happens for the next 4 or 5 years, is you end up with a business case where an integrator comes in, provides virtual from a server farm where you put all your kind of like eggs in one basket, sort of, but you have backup generators, backup servers. You can
separating the CMTS from the Remote PHY. And then Asaf, what you had talked about earlier was putting the CMTS in kind of like a virtual world, or that's virtualizing the CMTS, or putting it into a container. So
yeah,
I still don't think we've really necessarily communicated enough what that process of. I mean, I think we understand separating the CMTS from the Remote PHY because we've talked about Remote PHY before. And sorry, John, I interrupted you, but you froze up a little bit there. We haven't communicated enough exactly what that process is of virtualizing the CMTS and exactly what that means. So
yeah, I think first of all, John made some great points. I think the enablers today to allow for virtualization to happen is, number one, Remote PHY. He mentioned it. I couldn't agree more. Separating the software from the hardware. After all, there's always going to be that piece of hardware. The second thing is having it basically merchant silicon that allows you to have something that lives in that physical layer, that hardware component for a long lifespan, right? If the thing that goes out on the Remote PHY node has a short lifespan, is going to have to be replaced more frequently than we would like. But there is merchant silicon that has a long lifespan now. And the last one, which is very important, is you got to have off-the-shelf software processing capabilities that meets or exceeds the requirements for operations. And it does. I think Intel has done a fantastic job year over year having powerful CPUs, and they're doing fantastic work increasing that performance. And we obviously in real deployments we see that come to play. So those are the enablers for virtualization. And then in terms of virtualization, another point John made that was really good is the use cases. You know, with a virtualized approach, your first in cost could be very small. So having a small scale deployment is very easy when you have maybe a Remote PHY node or a few of them, and only a server or two, if you're talking about redundancy, connected to those. So you know your first in install in terms of space and power for hospitality, but for any other deployments that have a small service group sizes, your first in costs are very, very manageable as well. And Brady, you were mentioning, what does that mean? What are you virtualizing? So when we look at virtualization, and I've written this the past couple of years on other SCTE papers, we're talking about virtualizing not only the data plane, the management and control planes, but also the data plane. So taking all the packet processing, all the scheduling, everything in a software solution. So it's portable. First of all, you're not dependent on any unique hardware. Two, it works on off-the-shelf Intel servers, so you could leverage the annual growth benefits and performance. And third, that you could actually locate that software that's running on those servers in different locations. So it gives you that flexibility of co-locating the servers with a remote PHY device, or putting it in a hub, or taking it even more centrally in your network when you're aggregating a lot more of those remote PHY links. So those are all great opportunities that that virtualization provides. You know, there are other really key benefits. Virtualization, I also think, is agile development. There are a lot of features that are coming out, a lot of services that are going to come out, things that we can't predict. There's competition in the industry, and with agile software development approach, we're able, as an industry, to react to those needs much faster and deploy them. And in your article, you mentioned this as well. You mentioned snapshots and virtual machines in your article. Well, you don't necessarily need to use virtual machines, but you can use a high availability and hitless software upgrade method, where you can actually deploy software on a single service group and not impact all the other service groups running on a single server. So you get this great ability to isolate what you're doing and to do it in a very agile way. And I think that's very important to the industry, is how quickly we can compete with speeds and services.
Okay, and you mentioned virtualizing the data plane, the scheduler, and stuff like that. I mean, you're basically saying virtualizing the guts of a CMTS, maybe with the exception of the F connectors and stuff, because that's still going to be, that's like the remote PHY device, right?
That's exactly right. We're talking about, there's something doing a modulation and demodulation, the physical layer, obviously the F connector, but then everything above that running in software, everything. That includes all the things you mentioned: Volpe functionality, the BPI functionality, the scheduling functionality, obviously all the data plane OSSI functionality. All those things are running in software from soup to nuts, you know. So
right. And you've mentioned Intel a few times, but that's, you know, from the Intel standpoint, that's just talking about regular servers that you're putting this into.
Yeah, I remember when we first had this idea a few years ago. If you guys are familiar with Fry's Electronic.
Yeah, I love Fry's.
We sent a couple of guys down to the local Fry's and said, hey, go pick something out over there, bring that back over here, and you know, try this out. And lo and behold, I mean, the reason we went to Fry's as a joke, I mean, is because we really wanted this to be off the shelf, something that anybody can go purchase, and there isn't any unique special something running in hardware over there. And the reality is that's possible, and it's possible to do it in a very high performing way. And of course, there are requirements. If you use a stronger CPU, you're going to get higher bandwidth. You're going to get higher packet rates. If you're going to use a less powerful CPU, so there's definitely a performance power cost curve there, depending on what you're trying to do and which site. So.
Yeah. And for our listeners, if you've not been to a Fry's before, it is like a warehouse, a mega warehouse electronics store. So if you're a geek like us, it's kind of like going into just the most awesome electronics store you've ever been into. It's fantastic.
It's Geeks Disneyland.
Yeah, it's the best. John, that's the perfect way of saying it. It is the Geeks Disneyland.
Yeah.
So let me add a few thoughts. I've talked with some of our guys, and we're kind of using we started out very simplistic and said, let's do virtual CMTS. And that was basically taking the CMTS scheduling and put it on a server. And now we've evolved to call that cloud CMTS. It's not just semantics. It's not just it's a big change in how things will go forward for this cloud CMTS. I don't have all the details. Will never claim I do. It reminds me of when we used to see PowerPoint presentations and the IP guys would show the HFC in a cloud, an HFC cloud. I'm like, there's a lot more that goes in there than just some basic vapor.
Now it's the CMTS cloud.
I know. Where's the silver lining on that cloud? But some of the guys are explaining to me something called Kubernetes, open source, containers. And I think, Asaf, you mentioned, the granularity of service groups and upgrading service groups and even features like load balancing and scheduling and resiliency. And a lot of features we help keep our cable modems up and running properly. We might have updates for that normally would require a maintenance window to upload to a CMTS and take the CMTS down during the middle of the night from 1 to 6 a.m. And that CMTS can only handle so many service groups because of the form factor and how much powering. Now we're like, well, we can replace that CMTS with the servers. The servers are much smaller. And I asked, I'm like, could I make a blanket statement and say, will this server 1RU replace 2 CMTSs? Well, not today. We're not when you're talking about processing power and trying to do DOCSIS 3.1 and all these scheduling. But I don't know if it follows Moore's law or not. But the servers are getting smarter. They're getting faster. They're getting more cores. So eventually, one server might just do more processes or might be able to take the place of an entire CMTS. Our CMTS is 13RU. If I can replace that with 1RU, great. Now, if it's 2RU because I'm doing redundant servers, that's fine also. But I'm looking at powering, rack space. Then I say, well, what about all the splitting, combining I had to do with RF? Well, all the RF is out in the field now at Remote 5, but we still have optical splitting, combining. So we're replacing coax cable with fiber. We're replacing splitters and combiners with switches, but we're doing everything in the digital world. So it's a lot easier. It's faster. Updates there from 10 gig to 100 gig. So yeah, things keep moving along. We still have physical layer stuff, but DOCSIS just seems to keep evolving like every 3-4 years. Just when you think it's going to be the end, we keep evolving. Now we're taking 3.1 and going to different architectures and stuff like that with Remote 5 and virtual. I don't know if this eventually we start calling something DOCSIS 4.0. I don't know if there's talk about going from 3.1 to a new name. But normally when we go to a different DOCSIS name, it's new. Maybe FDX, right? If we go FDX full duplex, then we're talking about a new modem as well with echo cancellation.
Yeah. So, I mean, you guys are, the exciting things that you guys are talking about from at least my perspective is like the redundancy standpoint, because, being able to add just an additional server to add redundancy, the maintenance window aspects of this is, being able to add or being able to upgrade just a single service group instead of upgrading the entire CMTS. These are things that, from my perspective, are really exciting. As anyone who's done maintenance windows before knows how painful that can be, especially if you have to do it multiple times because there's issues. Those are really exciting aspects of virtual CCAP, the topic that we're talking about. What are other things that you see as benefits from virtualization? And I mean, John, you mentioned cost and power savings. Are there other things that you're seeing and looking into the future that would benefit the cable operator?
Well, you mentioned that the server, I could add the server almost anywhere. I mean, you could have a server farm in the middle of the East Coast somewhere serving the entire East Coast. We're not limited to 100-mile DOCSIS, like we used to be, having a CMTS within 100 miles to the cable modem. We're limited to from the Remote 5 to the cable modem, that's RF, so that's going to be within 1 or 2 miles because it's coax. But the digital link from the virtual server to the Remote 5, that could be 1,000 kilometers. That could be the entire East Coast. I mean, there's quite a you can you can imagine, you know, the capabilities there. Are you collapsing hub sites, collapsing head ends, maybe, possibly?
Right.
Yeah, those are all good use cases. I would say operationally, I see benefits that are like smaller failure domains, right? I mean, it used to be that your failure domain used to be a particular size with the CMTS, and depending on how you virtualize it and using containers, you could definitely have smaller failure domains. I mentioned the upgrade window and the time associated with that, but when there is a failure, it's obviously contained. It's much smaller, number one. Number two, I would say there's an opportunity around orchestration, right? So it's about lighting up services. And if you think about remote PHY, you're going to have lots of nodes out in the field, right? There's going to be an increase in scale of those remote PHY nodes out there. How quickly can you turn them on? How great can you orchestrate these things operationally? Those are all benefits of virtualization as well. And there's economies of scale. Virtualization in many ways isn't new. I mean, it's new to the cable industry or to CMTS, CCAP land, but at the end of the day, there's tons of tools out there that are leveraged in so many other industries that are performing so well, and we can leverage those benefits. We don't have to make a cable-specific solution to relish from those great benefits. John mentioned open source. Yeah, there's stuff out there that has been vetted out and is being used in the industry, and we as an industry should make the most use of that, right? It's for the benefit of the industry. And I mean, we can debate the different method of how to virtualize, whether you use virtual machines or you don't, and whether you use containers or Dockers or you don't, or you do things with cloud native, or I mean, those are all kind of nuances, and there are trade-offs around that. But the premise, the idea of virtualization and taking something that was very, very tied to a hardware platform that needed to be replaced, debatably, either through line cards or chassis every 3 to 5 years, now, you know, has a huge, long lifespan, and you can leverage, let's say your CPUs aren't powerful enough, you can add new generation servers to, let's say, a cluster of servers, so they don't become obsolete. Or maybe you have a new location which can use the less power, need less performance, and you can move those servers away. So there's going to be a long lifespan associated with that. There's also sparing benefits associated with that when you think about eventually maybe hardware failures on the servers, having sparing associated with any off-the-shelf server that you could put out there and run this on. So I think operationally it's going to be a huge gain in terms of service uptime, service turn on time, which you know, what did you say, a 1 a.m. to 6 a.m. Maintenance window?
Yeah, typically.
So,
yeah, that's normally the best time, the time that operators give you to work on the CMTS. All the 1 a.m. to 4 a.m. maybe is more common that you work on it.
yeah.
I said 6 a.m. because things always go bad.
Yeah, at 4 a.m. it's still not working, and so you end up working on it till 6 a.m. and then people are saying, okay, people need their ATMs back online, or cash machines and phones, and yeah, pressure really starts building on you then. So that's why I said I love that concept that we could just work on one service group, you know, that node that there's only a few rural people, you know, just a few people on it, and make sure everything's working there, and then we push it out to the rest of it. That's a very exciting thing. However, on the flip side of it, if I'm a cable operator and I feel really confident in my hardware-based CMTS, where I know everything's running on FPGAs and ASICs and things that work really well, and I look over at my Windows PC that's sitting there with a blue screen of death on it, and you tell me, okay, we're going to take out that hardware-based CMTS and we're going to put an Intel PC or something running with a CMTS, I'm probably going to be a little bit nervous. So this probably has to be something that has been a discussion that's gone on. How are operators looking at virtual CMTSs and saying, well, am I going to get the same reliability? Am I get, you know, how does software work compared to hardware? hardware's been working really well for me. So what's the, how do we look at it from that standpoint?
Yeah, we're not using Windows as our operating system.
Not Windows embedded?
Yes, not well. Bill Gates just stopped using his Windows phone, right? And moved to an Android phone. He didn't quite move all the way to an iPhone, but when Bill Gates stops using Windows
That's saying something.
embedded, I don't know. I mean, I do remember Spectrum analyzers going from some embedded OS, and then all of a sudden getting a blue screen of death. I think that was in the early 2000s, where folks were trying to run Windows NT as the embedded operating system for some Spectrum analyzer, and I got a blue screen of death while connecting some stuff. Lesson learned: we're not using Windows. So, first of all, is it a concern? It doesn't come up as often as you'd like, but of course it is. I mean, stability and reliability of software is a big deal. There's no question about it. And if you have software, you have bugs. Let's not kid ourselves. By the way, when you have hardware, generally speaking, hopefully if you're using silicon, you have an ASIC, it's bug free, it's gone through verification, but there might be a few spins along the way to get that pristine production silicon. But folks who are using FPGAs and DSPs, there are certainly bugs that come up on those, and those take time to fix. And I would say the penalty of getting it wrong in those products in an FPGA, DSP, or silicon solution is quite, first of all, it's expensive, but it's a lot of time, right? If you have those types of issues. In software, the benefit is you will have issues, but you'll solve them quickly, number one. Number two, if you've implemented high availability correctly, and you certainly can, then when you have a fault occur, whether it's a logic fault or a process fault or whatever software fault you can imagine, you could catch that, capture that, detect it, fail over, and keep services running. Harmonic has proven that out. We've done that, and certainly there are bugs. The question is, can you catch them and maintain services with no service disruption? And the claim is, yes, you can do that.
And it might be just one process that goes down. So you're not failing over completely from one server to another, like from a CMTS to another CMTS. You might be just failing over maybe one process from one server to another.
For example,
plus or something.
Yeah, and you talk about a process failing and catching it and moving that. There's also the opportunity when you upgrade something, when you do find that bug, it's a logic bug. Maybe you change your code in a single package, in a single container, and you do that without even modifying any of the other software. I mean, the opportunities are quite varied in your ability to be responsive in a software-based approach, where if you had an FPGA down, you'd probably have to upgrade the whole CMTS. You'd have to put the FPGA, embed it in some ISO image, and then download it, and bring the whole bring the whole image down to all the different line cards on that CMTS.
Good. So I think that sort of addresses a lot of the concerns there. And I think, to your point, I've spent a lot of years working with DOCSIS, and we've seen a lot of bugs that are in CMTSs and cable modems. And to your point, it does normally take a long time to fix a bug that's in hardware. Whereas if it's in software, ideally we'd be able to fix those much quicker, and hopefully it impacts much smaller service groups, to your point. So maybe it will be even more beneficial once we're virtualized.
Yeah, and I think another nuance to that is when you do have some fix to let's say an FPGA has an issue and you have that fix, and it took you a long time to get there. You basically have this one version of FPGA, and you push it down, and you're hopeful that it works out in the field. With a software-based approach, you could fix that bug, let's say, much quicker, and you can then isolate that deployment of that fix to a single service group, and then you could check it out without impacting everybody else running. And then if it proves out correctly, then you can expand that deployment or recorrect the fix, but at least you isolated. That's like, basically your failure domain or your blast radius is a lot smaller. There's a huge operational benefit to cable with that methodology.
So where do you guys see that we are in the life cycle of virtual CCAP?
Well, we're just starting, I guess, right? I mean, factually, we have a few deployments, so I could speak to it that it's real, and we have live deployments in North America and in Europe, and it's going well. It's going well, but there are a lot of lessons to be learned. I'm sure we'll continue learning them. There's performance to gain year over year. And as we learn how operations, some new operational benefits year over year that allows us to do things quicker, faster, those are all things that will come above and beyond the initial deployment cycle of being able to replace existing services on CMTSs that are hardware-based. So we're definitely early on. I see a lot of growth in 2018 around this, not only with virtualization, but also with remote PHY. In many ways, distributed architectures and virtualization, while one isn't dependent on the other, you could do a virtualized deployment with the centralized architecture. I am a big fan of DAA and remote PHY in particular, and see that the two things are going to get to some sort of inflection point in terms of deployment in 2018, across the cable industry. So the future is bright.
Yeah, I mean, I think that, we can always step back and say, well, why don't we just do fiber to the home? That always comes up. Remote PHY getting deeper and deeper. And I said it before, it's not the last mile anymore, it's the last 100 feet. So even do a remote PHY to a tap where the drop cable is still there, that's still more economical than trying to run fiber to everybody's home. It still comes down to money. If money wasn't the object here, then we would just run fiber right to your eyeball, and we'd be done with it, But there's still cost associated with all this, and then also ripping out the existing HFC plant. So we're pretty much embedded in from the last 50 years or so, or more, 60, 70 years, with coax in the U.S., maybe not in other countries. So remote PHY is a big one, getting to that, getting a digital optical link, get rid of the analog optical link, taking our amplifier cascades down to none, getting the coax as short as possible. We get rid of the coax, we don't have the tilt problems, we don't have the attenuation issues. We could start doing maybe FDX, the full duplex DOCSIS, where we can run the upstream and downstream really at the same frequencies. We can offer 10 gig speed up and down. That gets us really high speeds. I like the idea or what you brought up about orchestration, because some of the things we overlook, like how am I going to operationalize this? If I have all these nodes out in the field, how do I keep track of them? How do I set them up? How do I configure them? I don't want to be running iOS in a node. That's sort of why I never saw the MAC-PHY happening in the node. Just keep it simple and just do the PHY, remote PHY in the node. But orchestration is a big one. And what I've seen us looking at, Cisco, was maybe like a smartphone with an app on it where you would scan a barcode or a QR, and then as the technician scans it and deploys it in the field, it actually tags a lat long on there, GIS or latitude, longitude. So it actually knows, and it uploads it to some type of mapping software, and then it's all part of SDN and this orchestration.
Yeah, those are great points. I mean, we want to make this as operationally familiar initially. Cable operations, has a method to it in terms of deployment of nodes and deployment of CMTSs. So, I mean, you're still going to have, the field tech that's going to go out there and deploy the node. Scanning a QR code is simple enough, and that's something that actually we did at the last SCTE. We were scanning QR codes at our booth, making it operationally simple. And then, all right, we're going for a walk, huh?
Everyone should be seeing your face and not mine.
I know. But I see you going for a walk, so I love it.
You're listening to the audio only. John and I think is going for a beer now on Friday afternoon.
Good idea.
Yeah, I'm done with my competition, so now I'm going off the deep end.
I love him in the rocking chair too. By the way, when John gets in a zone, he starts rocking back and forth even more. Great. But so that's on one side, which is on the node side. You got to make it simple, easy, and scalable on deploying those remote PHY nodes. The second piece operationally is, while you can start using all kinds of cool orchestration and virtualization tools, you also have to have CLI, SNMP, IPDR, all the things that make it familiar and that plug into an existing network. And that goes without saying. And the benefit going forward, of course, is that you can make that more seamless, operationally easier, and again, scale of deployment, ease of operations and monitoring. Those are all great benefits that come out with the virtualization approach.
Okay. Anything else you guys want to cover on virtualization? I've got one Q&A question that I want to cover before as we wrap up here. So anything else on virtualization covered up? I will say, go ahead, John.
Come and hear our talks. Come and hear John's talk on what was it, Wednesday, and mine. I'm sure we're going to cover a lot of things that are related to that. So.
Yeah, I think two hot topics that we're going to see a lot at if you guys are going to Expo, our listeners are going to Expo, you're probably going to see remote PHY and you're probably going to see some virtualization at Cable Tech Expo this year. So check those demos out that are going on. So I have a backlog of questions that have been going on. I just want to cover one of them, and I think you two will feel comfortable covering this topic. It's on DOCSIS 3.1. So one of our listeners has written in. He says, I recently took my DOCSIS 3.1 certification through SCTE, so congratulations for taking your certification. I have been posting info in a channel I created on Yammer for our company at a major MSO. One poster asked why OFDM reads 4 to 8 dB gains better than SCQAM. Just a field tech. So first of all, I want to tell this poster, you're a field tech. Don't say you're just a field tech. You are the backbone of the cable industry. And so, congratulations for being a field tech and keep up the good work. He's a field tech, and he's taken huge interest in knowing more about the ins and outs of DOCSIS 3.1. Can anyone give him a more definitive answer on why OFDM performs better than SCQAM? So I'd like to throw this out.
Why it performs better, or it is reading better MER? Was there?
So so they ask why OFDM reads 4 to 8 dB gains better than SCQAM. So I'm suspecting that in their system it's 4 to 8 dB gains than SCQAM. So I'm guessing it's MER that they're seeing better performance.
Let me address that. What I've seen lately on our own was some modems, I believe, are incorrectly reporting the MER of the pilots. So those pilots are 6 dB higher than the rest of the OFDM channel.
Right.
What's supposed to happen is we do get the MER of the pilots, the scattered pilots, and 6 dB to give you the equivalent of where the subcarriers really are, the active subcarriers. So I've seen some modems report MER like 50 downstream MER, and the other one's 44. I think the 44 is actually correct. And then I would use my $100,000 Rodian Swartz test equipment, and it would give me the MER of the pilots and the subcarriers. So basically, minus 6 dB. And I think that might be what's happening is it's giving the MER of the actual the pilots. Because we all know the pilots are just doing BPSK 6 dB higher than the rest of the OFDM channel or the subcarriers.
Right.
This is out of my field of expertise for sure, but if we're comparing the same order modulation between SCQAM and OFDM, and I'm assuming they are, isn't the forward correction with OFDM with LDPC going to give you some gain? I think I remember 3 dB. But again, it's outside my area of expertise, but I definitely thought that there was some benefit to that in terms of improving your MER.
See, Asaf, I was actually thinking more along your lines, that this was my answer would have been that your performance is going to be better due to the LDPC, or low density parity check. And so we're actually getting better performance with OFDM in the same environment that an SC-QAM is, and that performance is better because we've changed error correction. So with SC-QAM, we have the Reed-Solomon error correction, which is kind of an okay error correction. It's the one we've been living with DOCSIS 1.0, 1.1, 2.0, and 3.0. And then in DOCSIS 3.1, where we have OFDM signals, we add this really, really awesomely robust error correction called LDPC that just kicks butt. And it gets us almost what we call, near Shannon theorem, where it's almost as theoretically good as we can possibly get. So that was kind of the way I was thinking. I hadn't considered what John mentioned, where we're looking at the pilots that are 6 dB higher and running in QPSK. So
let's look at it this way. Actually, it's BPSK. The pilots.
Yeah, BPSK. Yeah.
So let's look at it this way. Do LDPC and the forward error correction make it more robust, which allows it to work in a lower MER, or does it actually make the MER better? Now, the MER is a physical layer, but it's after the chipset decodes it. So are we mixing up CNR with MER? Like, where is that reading coming from? Is it before some of this stuff is decoded? Well, technically, MER should be after it's decoded, right, from the chipset?
Right. Yeah.
So it's funny, it's like, now we look at this deeper, even though we're supposed to be the experts. I really felt that the MER would be the same readings no matter what the modulation is. It's just the fact that this LDPC and how the FEC works, it actually performs better at a lower MER. But the recording is still the same.
It basically gives you headroom, is what you're saying, and basically the MER is what it is, regardless of anything, and the LDPC just gives you that headroom to operate at a lower MER at a higher modulation rate.
Exactly, because if you look at the tables in the DOCSIS 3.1 spec, it'll show 4K QAM needing, I think, like 41 dB MER or something like that, and we know it's like 6 dB conservative, because I've seen 4K.
We actually need less than.
Yeah, it worked at 35, and I was like, wow, it works. It's more robust than I thought it was. That's unheard of. So I really do feel like the MER is what it is, regardless of modulation running. And you really probably should have the same reading between a single carrier QAM and OFDM, because it's still the same amplitude to noise floor. And I think maybe some of the readings the gentleman is referring to could be incorrectly being reported from the cable modem, because it's looking at the pilot tones that are 6 dB, running 6 dB hotter. Okay. In my opinion.
We'd have to retitle this "Stump the Chumps." All right. Well, that was a good question, and also a good coverage of virtual CCAP. So, Asaf, thank you for joining us today, and we certainly hope to have you back on a future show. And John, thank you again for joining us. I will look forward to seeing both of you guys at Cable Tech Expo. Hopefully we can get together and meet up and chat a little bit, maybe have a beer or something like that, and talk some more about DOCSIS and all things RF. So, all right, gentlemen, thanks. It was a good show. We'll meet again. All right.
Adios.
Take care, everyone.
Thank you.